Okay, so guys, we're gonna start part 2 of this. And if you don't remember before, we were identifying the zeros of radical functions. So that's just a single number where the object crosses the x-axis. So here's my zeros. I'm circling them right now, and then I'm going to go back and write the numbers. So here, x equals, let's see, -1, -2, -3, -3. Over here, x does not exist, D and E. Okay, and then here, x equals, let's see, 3. And for 18, x equals, looks like 2.5. Okay, now that's graphically. Previously, we got the zeros algebraic, like with our calculator. And if you don't remember how to do it, I'm just going to go back and do number 12 with you. So number 12, I'm going to go to my calculator, go to y equals, put it in y equals, so I clear what's in there out, clear this out, press second x squared, x plus 3 inside of the radical, and then plus 8 on the outside. And we want to find the 0, so we press trace just to look at it. I'm going to look at it. It's way up there. I want to change so I can see it a little bit. So I like to do zoom fit. And it looks like, I'm just going to go back to zoom 6. It looks like this does not cross the x-axis. So there's no way this has a 0. So here, x does not exist. It doesn't exist. It's too far above the x-axis. Number 13, putting it in, go back to y equals. And you understand, number 12, you don't have to use the calculator functions to find that 0. You do not have to use the calculator functions to find that 0. So I'm just trying to minimize this. Anyways, so I clear this out, put in number 13, and I have -2 second square root of 6x minus 3 parentheses minus 10, and I press second trace, and I go to 0, number 2, and I might have done that prematurely, so probably I should have looked at the graph first, and I should have, so I'm going to press window, and zoom, and 0, to kind of hopefully find out where it's at. And there's my curve. So I want to know if this goes up. So what I'm going to do is go to my table, use my table, and see if it goes over 0. And it does not. It does not. It looks like the highest point is -13.46, and this 0 just does not exist. On the other hand, for number 14, there is a 0, and you're going to use the same function to do that. So I'm just going to go ahead and do it, and go to the right arrow, clear, 14 plus 4, math, number 4, for the cube root function, 7x plus 3, close parentheses, press trace so I can see if I can see it, and I cannot, so I'm going to press zoom, zoom 6 and try that, and there's my curve. Let's make sure I put that in correctly. 14 plus 4 cube root of 7x plus 3, yeah. Okay, so I'm getting the 0, so I'm going to press 2 and go to the left of that 0, So you see my cursor coming down. So I'm moving to the left of where it crosses the x-axis. Press enter, and I move towards the right where it crosses the x-axis. Press enter and enter again, and I get negative 6.55 is my zero. X equals negative 6.55. Okay. Now, we're going to move on to, we did that to kind of make the connection between solving algebraically for the zero. So you can do that with the radical. So the first thing we're going to do is isolate the radical. So what does that mean? We want this by itself. So the things we have to move, I'm going to do it in pink here, is this 1. We move that 1 first. We add or subtract numbers away first. All right? So let's make a little note. So the number that's added or subtracted here is in pink. So I'm going to highlight that. I'm going to highlight my first step. I'm getting rid of that 1 first. Any number I add or subtract, getting rid of it. And then the second step would be to get rid of any numbers that I'm multiplying or dividing. And then I deal with the radical. And then I deal with the radical. So that would be the 3. So here, multiply or divide, we do the opposite. Any numbers away second. So we're going to go through the rules here, but that's basically what we're going to do. And then we're going to square that radical. Okay, so we're going to do step 1 first. So it says isolate the radical to one side of the equal sign. So here's my radical. It's in yellow. So what I'm going to move first is I'm going to move that 1. So I'm going to subtract 1 on both sides of this equal sign. And I bring down 3 square roots of x. This goes away, equals 12. So that was step 1. That was step 1. I got rid of the number that was added or subtracted. I don't want to do that in green. So I added or subtracted first, a number away. Okay, that was that. Now step 2, we're going to get rid of the number. We're isolating the radical much like this absolute value. So we're going to divide 3 on both sides. All right, and we get the square root of x equals 4. Now, all right, very next step involves what we do to the radical itself. So I'm going to write what we do over here, and then I'm going to read through what it tells you to do. So the last step should be you squaring both sides and simplifying. Okay, so squaring both sides and simplifying. So it says the radical is a square root, and it is. We'll square each side of the equation. If it was a cube root, we would cube each side. If the radical is not a square root, raise each side to the power equal to the index of the square root. So I told you square both sides and simplify. So I'm going to square both sides. So that means I'm going to put parentheses here and parentheses over here and a square symbol to get rid of the radical. Okay, and I have x, this equals x over here, and then 4 squared is 16. So x equals 16. Now, solve the resulting equation, And I already did that. X equals 16. Now I'm going to check my answer by plugging the 16 into the X. And I get 3 square root of 16 plus 1 equals 13. What I end up with is 3 times 4 plus 1 equals 13. And I get 12 plus 1 equals 13. And so it checks out. So I put a check there. And my answer is X equals 16. Okay, so that's us checking the work. So I'm not going to do, let's see, all right, so I'm going to do example 1 and example 2. So first step, we're going to add or subtract a number. We're isolating this radical to be by itself. So the numbers I can add or subtract would be 5. So I add 5 to both sides. 5 over here. I get the square root of x coming down. This goes away, equals 6. Now, in order to finish solving for this radical, I have to square both sides because there's no number to multiply or divide, so I skip that step. Okay, and I get x equals 36. Final answer. Next one, add or subtract a number. Just highlight is my radical. So I'm adding or subtracting and multiplying or dividing. So add or subtract first. So subtract 6 on both sides of the equal sign. I get 4 square root of x coming down. This going away, equaling 12. Divide both sides by 4. And the square root of x equals 3. Square both sides. X equals 9. Okay? Easy stuff. Next one, subtract 6 on both sides to isolate that radical. Get the square root of x equals 3. Then I want to square both sides of this equal sign. And x equals 9. Final answer. Moving on, we're going to go to more complicated problems, so just ignore the top part. Same stuff. So same rules. Always adding or subtracting the number away first, checking to see if we can do that. Then multiplying or dividing a number away from that radical first. Then squaring or doing whatever it is both sides and simplifying. All right, so if you can't recall what that looks like, what do we do first? Here, adding or subtracting a number away first, that will be 5. And then I'm just going to coordinate with the colors I had before. So adding or subtracting a number away first, that would be 5. And then multiplying or dividing a number, that would be that -2. So two numbers we'll be working with 5 and -2. Okay. So I'm going to subtract 5 away first, and I'm going to use purple. So -5 on both sides. The difference between the radical from last time is that there's more than one number under that radical sign. So we're going to have to do an additional step after squaring both sides and simplifying. But this goes away. This becomes -2 times the square root of x plus 1 equals -6. Divide both sides by that -2 to get rid of it. And now we've isolated the radical itself. So all we're going to be left with is this part. With that color, sorry. Bless me. All I'm going to be left with is this part. Okay? Anyways, get back to business. That leaves me with the square root of x plus 1 equals 3. Now, in order to get rid of the radical, what we did before, we squared both sides. But now we have an additional step. When I square both sides, just pulls off the radical. It just pulls off that radical. Very radical, what it does. Equals 9. This very new step, I'm going to type it out here. It's solving for x. Solve for x. We just got one additional step. Solve for x. So I'm going to do that. I'm going to subtract 1 on both sides. The equal sign. I get x. This goes away. Equals 8. X equals 8. Alright, so I'm going to check my work. So I have 5 minus 2 square root of 8 plus 1 equals -1. And I get 5 minus 2 square root of 9 equals 1, -1. And I get 5 minus 2 times 3 equals -1, or 5 minus 6 equals -1, and the statement is true. So this checks out. All right. We're going to do example 1, and here we're going to be using the cube root function. So at the end, we'll be cubing both sides. In example 3, we're using the nth root, the fifth root, so we'll be fifthing each function. So let's see what we're doing first. So highlighting, I'm going to be adding or subtracting a number first. So I'm just going to go through and highlight the numbers that I add or subtract first. And then I'm going to be multiplying or dividing a number. And then I'm going to have this radical by itself. That's what I should end up with by itself. Okay? And then I have to do that additional step. So, going through the motions, I subtract 5 on both sides of the equal sign. Get to the cube root of x minus 3 equals 12. Okay, now second step, I'm going to divide both sides by that number, or 2, that coefficient of that radical, and I get the cube root of, x minus 3 equals 6. Now, if I want to get rid of the cube roots, I need to cube both sides. It's not a square root. If I want to get rid of the cube roots, I need to cube both sides. And what I end up with is x minus 3 equals 216. Okay, add 3 to both sides. And x should equal 219. X should equal 219. I want to check my work, so I'm going to go put this back in. 2 cube roots of, let's type this in, 219 minus 3. That's inside the radical. Plus 5 on the outside. Plus 5 equals 6. Now, 2 times the cube root of, let's see, 216 plus 5 equals 6. That's what it says. Well, 2 times the cube root of this, which is 2 times 6. 2 times 6. Let's make sure I did that right. Over here, oh, it's 17 on the right side, sorry. This is 17. So make that correction, 17. So 2 times 6 plus 5 equals 17. And it's true, and it checks out, so it works. Okay? You can do example 2 and example 3 on your own. Okay, so what about when there's 2 additional variables? Actually, let me do example 3 with you. So example 3, same stuff. So subtract 2 on both sides. I just won't check the work. You will just have to do that. And I get 3 times the fifth root, the fifth root of x minus 1 equals, what's this, 15. Divide both sides by 3. And I get the fifth root of x minus 1 equals 5. Square both sides. I mean, not square, but fifth root both sides. So put it to the power of 5 on both sides. And I'm actually going to use my calculator here because I can't do all of that big work inside of my head on the right. So I have this just eliminates the radical on the left hand side. But 5 to the 5th power, I'm going to go second mode, 5, up arrow 5, and I get 3125. Subtract both, do the opposite, so add 1 to both sides. And I get that x equals 3126. For example 2, you don't have to do that work like that. Because all you're doing is squaring. And actually, I'll just go ahead and work through that with you. So I'm going to add 10 to both sides. And I get negative 4 square root of 2x minus 2. This goes away, equals 16. Okay? Divide both sides by negative 4. And I get this canceling, I get square root of 2x minus 2 equals negative 4. Square both sides of this radical, because that's what I'm working with. And then I just solve for x. So I have 2x minus 2, it just comes out of the radical, equals 16. Divide both sides. Oh, not yet. Equals 16. Add 2 to both sides. And I get 2x equals, this goes away, 18. Divide by 2. And x equals 9. Final answer. Okay, the last one is when you have a variable on both sides. So if you don't have anything outside to isolate, you don't have to add or subtract. You don't have to do all those things from before. So we're just going to write the steps that we've been going over so far. So step 1, you add or subtract the number away. Okay. Step 2, multiply or divide a number away. Step 3, square both sides. Step 4, simplify. But now we might have an additional step, so we're going to see what those things are. So first, we're going to just go through the steps. We don't have to add or subtract a number. We don't have to multiply a number. So that means then the next step we're going to do, the very first step here, we're going to square both sides to get out of the radical. And then we're going to solve for x. So square both sides, I get 30 minus x equals x squared. Now, so here, what we're going to do, we're going to actually, in fact, factor everything. So that means I'm going to move 30. Remember, when you move a number to the opposite side, it just becomes the opposite. And then I am going to move x over as well. So it becomes positive on the other side of that equal sign. And as a matter of course, 30 minus 30 is 0. X minus x is 0, so I'm left with 0 equals. And on the left, I have x squared coming down plus x minus 30. So if you go to your calculator, go to apps, and go down to poly simulations and put this in. Poly simulations, put these numbers in. It's easy to factor, relatively easy. And what you'll find is you'll have two numbers. So number in front of x squared is 1. Number in front of x is 1. Number in front of the last number is negative 30. Press graph for solve, and I get 5. X equals 5 and negative 6. So check my work. 30 minus 5. Square root of 30 minus 5 should equal 5. Okay, so the square root of 25 does equal 5. Now, on the right, the square root of 30 minus this negative 6 should equal negative 6. So the square root of 25 equals plus or minus 5. Equals plus or minus 5. Here we get the square root of 30. And I get square root of 36. And I get positive 6 back, but it's also true for negative 6. So with these, the one, you're going to take one away. So make a note. And let's go check in our graphing calculator here. Let's go put this in. And we have clear. Let's second mode here. So with these, you have to be careful. It gives you two results, but the problem with problem with one of them is that you don't end up with the same thing. So you always have to eliminate one. Graphically, you can see it in your graphing calculator. Like if I were to graph this equation in my graphing calculator, I already plugged it in. But if I were to graph it, I would not see -6 as a 0. I'd see 5, but I wouldn't see -6. So be careful. Here, when you have variables on both sides, check your work and make sure that both answers are valid, algebraic. Because you don't have these two answers. If you put those two answers, I'm going to mark it wrong. It doesn't work out for x equals -6. You have to check the work. Okay? So the actual answer here, the actual only answer you have is x equals 5. X equals 5. So I'm going to do one more so we're clear about that. So we're squaring on both sides. And I get 6x plus 16 equals x squared. And remember, if I'm putting something on one side, if I'm moving something to the other side of the equal sign, so if I'm throwing this 6 over to the other side, it's just going to change signs. It becomes -6x. Throw the 16, the positive 16 over, becomes -16. Okay? Use my apps function, and I find that x equals two numbers and multiply -16 are 8 and 2. So 8 and 2. Okay? I want to make sure that both answers are valid. Both answers should be valid. So I'm going to rewrite my function here, and I get, let's see what my function is, 6x plus 16. So the square root of 6x, or 6 times 8, plus 16 equals 8. Then on the other side, the square root of 6 times 2 plus 16 equals 2. So 48 plus 16 is 64. The square root of 64 equals 8. So the first one checks out. That checks out. All right. Second one, it's 2. 6 times 2 is 12. 12 plus 16 is 28. The square root of 28 does not equal 2. So 2 does not check out. My final answer is x equals 8. I hope that clarified some things there. That's pretty much it. Make sure you go back and do example 2 and some of the other examples in this unit. And you do have homework. That's your homework. Please, please, please do the work. Follow the directions. Have a great, great day, guys.